Hi everyone, today we are going to do the next part of light. Last class, if you will see, we had done till reflection, we had done numericals based on reflection, right? Today we are going to see completely about refraction, we will see refractive index, then we will see Snell's law, we will see optical density, and then we will see about lenses like lens ray diagram, image formation. Those things we will see in today's class, and uses also we'll see. Almost 90% of the chapter today's theoretical part we will finish off refraction, and the next class we will see numericals related to what refraction. So let's revise whatever we had done in what reflection, right? So if you'll see a reflection, then we did started with few formulas, right? Like because I cannot revise each and everything, right? So two types of mirror we learned. That is what concave mirror and convex mirror. So we can say concave is what this part is concave, this part is what convex. So we can say this is what concave. Well, the diagram is not good, but fine. Consider it as a concave mirror, right? And then we can say focus, pole, focus, and what center of curvature, right? So if you will take concave, then convex, pole, right, focus, and then what center of curvature. So these things we learned: pole, focus, center of curvature, radius of curvature, focal length. These all things we know. And then we had done 1 by f is equal to 1 by v plus of what 1 by u, right? That is the mirror formula. We did relation between radius and focal length, r is equal to 2f, that we did. And then magnification is equal to minus b by u or hi by ho, that we did. Magnification is greater than 1, less than 1. Those all properties we finished already. So you guys better revise once and then come to this chapter, right? Or you can watch those videos, three videos perhaps I made on like this light. So those videos you watch, then you come, that is going to be good for this chapter. So now we are going to see refraction of light, right? Let's see why refraction takes place. First, if you will take an example why it takes place, think about of that. If you are running, three mediums are there. First, if you are running in what sand, let's take you are running in water, like suppose beach, you are in beach. So first you are in sea, like you went little towards water, right? Then you will come to sand, then you will go to road, right? So three things are there: first water, then what sand, then what road, right? So if you run here, your speed is keep on increasing, right? If you run in water, your speed will be lesser, right? If you will go towards what is that sand, then your speed is going to increase. If you go on land, right, then of course road or land, then what will happen? Your speed will be the fastest there. So we can say our speed changes with medium, then of course light's speed will also change with respect to what medium. Now you guys understood why the speed changes. Ultimately, refraction is a phenomenon of changing the speed. Okay. Now changing the speed takes place in light little in a different way, right? That we can observe and then we can see also. Let's see. Suppose now here is what, if you will see a density matters a lot in refraction. Suppose if you will take water and you will take what glass. So glass is more denser, right? Obviously than what water. Water is liquid, right? Glass is what solid. So glass we can say more denser, and water we can say is what less denser, right? If you will take now glass, water, and you can take, let's take what iron, then obviously iron will be the densest in this all three, right? So likewise we can change the density value will what change by changing the medium, right? Now what will happen if a ray of light travels from denser medium to rarer medium? If a ray of light travels from rarer medium to denser medium, then what will happen? That we are going to see in this slide. Let's see. Suppose if you see a ray of light travels from rarer to denser. What is that, guys? Rarer to denser. Rarer to what? Rarer means what again? Less denser, right? Less density. And density is there less. So we can say rarer to denser if it will travel. So it is traveling like this. A ray of light travels. So this we can say what? Incident ray. And this we can say what? Refracted ray. Remember, refracted ray, not reflected, refracted ray. And this is, we can say what, normal. Okay, normal. And then what happens here is array of light travels, passes through rarer to denser medium, then it bends towards the normal. Let's see, guys. If you'll see properly here, one thing, we can say the ray of light was supposed to travel like this, right? But it went towards the normal. It bends towards the normal. So a ray of light travels from rarer to denser medium, then it bends towards the normal. Angle I, incident angle, is greater than what? Refracted angle, right? Why it is greater? Suppose this total angle should be what? Incident angle, right? But here is only we are seeing what? R. So this total angle, so this extra part is deviating this side. So that is what incident, if a ray of light travels from rarer to denser, then what? It bends towards the normal. Angle I should be greater than angle R. Let's see again. If you will see this, again, a ray of light travels from denser to rarer, then what will happen? Now see, a ray of light was supposed to go in this way, but it went extra in this direction, right? So we can say when a ray of light travels from denser medium to rarer medium, then what we can say? When a ray of light travels from denser to rarer medium, then we can say what? We can say it will bend away from the normal. It will bend away from the normal. Fine. So let's see again one more time. I'll tell you that what a ray of light travels from rarer medium to denser medium, then it bends away from the normal. Rarer to denser, away from the normal. Rarer to denser, towards the normal. Denser to rarer, towards the normal. Fine. Now what we are going to see is what, how refraction takes place in glass, right? Suppose a glass medium is there, or any denser medium is there, right? Outside is air, inside is also, like outside is like suppose air here, and then glass you put here. So again what? Air only. So what? First is what? Incident ray is on air to glass. So obviously bends away from the normal. Bends what? Away. Sorry, bends towards the normal. Rarer to denser, right? Now denser to rarer, away from the normal. So this is what I wrote. So angle I here, what will happen, guys? Angle I will be equal to what? Angle R. Angle I is equal to what? Angle E. E is what here? Emergent angle. Emergent angle. Okay. And then what we can say here? This rays of light. See, one more thing I'll tell you, an interesting fact here. That what this ray, wait, yeah, this ray, and then what, this ray, a ray of light travels from rarer to denser, then what will happen? Denser to rarer, then bends away from the normal, right? Bends away, this is the normal, then this ray was supposed to go like this. So if you see properly, both rays are parallel. Both rays are what? Parallel. So incident ray and this both rays will be what? Parallel. Fine. Now what? Laws of refraction. Laws of reflection. Refraction, if you will see, is Snell's law, right? What is that? The sine of angle of incidence to that of sine of angle of refraction is always constant. What is the meaning of that? Sine of angle, sine I by sine R. Sine I means what? This angle we are making, no? That angle by the lower angle, the refracted angle will be what? Is equal to constant. Let's see how we are saying. Suppose we took first is what? I1. So first we took what? I1. If you will take what, guys? I1. What they observed, that is what I am saying you. So first they took I1. Then they saw that there is R1, right? Then they took I2, and then they saw that R2. They took R1, then right, I1, R1, I2, R2, right? Then they again did is what? I3, they got what? R3. Then they found the ratio of I1 by I2, I1 by R1, and then I2 by R2. I3 by R3. Then they saw that the ratio is changing. Suppose it is changing 2, 2, 2 everywhere. It is like this. I1 by R1, I1 by I2 is equal to what? R1 by R2. And then I3 by I2 is equal to what? R3 by R2. So it is changing. The difference, if you will see the ratio, if you will see there, it is going to be what? Same. So that, okay, if the ratios are same, then we can say it is always what? Constant. It is what? Always constant. Let's take N2 N2 1 this is what 2 guys, this is a refractive index 2 and refractive index what 1. So a refractive index of N2 1 is means what, refractive index of N2 1 means refractive index of second medium with respect to what, first medium, with respect to what, first medium we can say. Fine, that is what we learned, refractive index of what, first medium to what, second medium. Let's see, we'll learn little more about what refractive index. Refractive index, if you'll see more little in depth, so what we can say here, what we learned, how we wrote refractive index of what, medium 2 by refractive index of medium 1. Think about of that. Suppose ray of light is passing like this. Right, so this is water and this is what, air, right, water and air. So if you'll write this, how we will write here, N2 1, right, that is what we know, N2, this is, let's take 2, this is what, 1. So what we can write here, N2 by N1. Okay, so same we can write water, air, so refractive index of water by refractive index of air. Hope so you guys got it. So this is the way to what, write it, how we will write. So next, if you will see, suppose this is normal incident here and then it is bending towards the normal. So let's take, here speed is C1, here speed is C2, right? Here speed is C1 and here speed is what, C2. Here medium 1 and here what, medium 2. Ray of light is coming like this. So let's see how we'll write. So N2 1, we will write what, N2 1 is equal to what, we can write sine I, this is I and this is what, R. Sine R is equal to what, we will write, speed of now 1 by 2, but refractive index what we are writing, 2 and 1, so we can write, okay, so refractive index if you will write and the speed if you want to compare, both are opposite, sorry, this is going to be 2 and 1, it's going to be what, 2 and 1, 2 and 1, so that is what, opposite, just you can note down this also. Let's see next what we are supposed to see here. Okay, now what, N2 1 we can write, if you want to find the reciprocal, right, N12, if you want to write what, N12, so you will write by of that, right? Suppose if they gave you refractive index of glass with respect to water, but you want to find refractive index of what, air with respect to glass, so what you will do, air with respect to glass, you will write by this way. Hope so you guys got it, right? So just opposite of that you are supposed to do. Now what, if you want to find what, absolute refractive index, what you are supposed to find, absolute refractive index. Okay, let's see, I'll do it because we have less space, I wrote something else there. Absolute refractive index, if you want to find absolute refractive index, then what we are supposed to see here, suppose a ray of light is traveling from vacuum to what, glass, from vacuum to glass, so N1 is this, N1 and this is what, N2. Now vacuum refractive index is going to be what, 1, so we can find here from here absolute refractive index. So what you will write, sine I by sine R, right, sine I by sine R is going to be what, refractive index of N2 by what, N1, N2 by what, N1, N1 of what, refractive index of vacuum is what, 1, so we can find directly what, N2. So this is, we can say, this is the way to write what, absolute refractive index. What is that, absolute refractive index? Fine, let's see, now we are going to find now next is about refractive index and optical density of a medium. About what, refractive index and optical density of a medium. So let's see, this I am going to do with an example. Right, let's see, normal first I'll draw. Okay. Now what? Let's take refractive index of this is what 1.33. This is 1. Let's take 9. This is 2.5. Right. Now first array of light travels from rarer to denser. Right. Rarer. This is rarer, guys, and this is denser. This is rarer. This is denser. This is rarer. This is what denser. Array of light travels from rarer to denser. What will happen? It will bend towards the normal. It will bend towards the normal. So we can say what will happen if it will come here. Array of light travels. It will bend towards the normal. It will bend towards the normal. Right, here is the bending. Now let's see. Okay, now if you'll see a difference here, let's take this angle is alpha, this is beta, this is gamma, then we can say obviously alpha is greater than beta is greater than what? Gamma. Oh, we can say one more thing from here, that what if the density will increase, optical density will increase, then what? Refraction will also takes place more. It means bending of the light towards the normal will be what? More. Bending of the lights towards normal is going to be what? More. Logical also, right? So that is here degree of bending. So degree of what? Bending is equal to refractive index of the medium. So this point you can write degree of bending is equal to refractive index of the medium. Refractive index of the medium. So that we can write. Fine. Now we are going to see what about lenses. Like two types of lenses are there, right? What are those? First is what? Convex lens, right? So we can say from both the side, this lens no is like this. So both the side is convex, right? So we wrote what? Double convex lens, right? One side is what? Plane, and then one side is what? One side is what? Convex. So plano convex lens. Now what is the major difference in convex lens is what we are supposed to understand from here is, see guys, this width is more, and then if you will see here, this width is what? In the middle width is less, right? So we can say that convex lens is going to be what? In the width it will be what? Like in the middle width is going to be more, at the corner width is going to be what? Less. But concave lens, if you will see, width in the middle will be less, and in the on the corners it will be what? More. Fine. So that is what we should understand from here. And now three different types of lenses we consider here. Acha, for lens, no, one thing is for sure, that one minimum one spherical mirror is required. For to make a lens, minimum to make a lens, minimum one spherical mirror is required. Spherical mirror is what? Required. Minimum what? One spherical mirror is required. Okay. So we can say convex lens, middle is more wider, right? So planar concave, if you will see here, yeah, right, this thing. So we can say middle, the width is more, right? Plano convex, if you will see, plano convex we have seen, then concave or convex lens. Ultimately, if you will see concave only, but in the middle width is more. So we are seeing plano convex lens. So if you will see concave lens, middle is what? Less, right? And then what? Plano concave, right? Middle is what? Less. And then here also convex or concave lens, because middle again what? The width is what? More. So these three lenses are there. Now what? Converging and diverging action. Converging and diverging action we are going to see now. So let's draw it properly first. right? So for this, we can say a ray of light parallel to principal axis will mean at the focus, right? Even for lens, for mirror, it is going to be what? Same only, right? So rays are parallel, so it will meet somewhere there. So this is what convex. Convex, so converging action. Converging action, right? Now if you will see this lens, then what? Array of light parallel to principal axis, right, will pass through obviously focus. But here the problem is what? Right, yeah, so it will go like this. Actually, I didn't draw it properly. Let's draw it again. Let's change the color first. A ray of light parallel to principal axis will pass through what? Focus. So it will bend like this, right? So now we can say a ray of light again, like, right? So this we can say so at the focus it will make, right? So this we can say what? Diverging action. See, rays of lights are what? Diverging. So diverging action, right? So convex will have what? Converging action, and concave will have what? Diverging action. Now what? Important rays, right? So this rays, now we'll see there also be option array of light parallel to principal. So let's see first is what? Convex lens. So array of light parallel to principal axis will pass through what? Focus. Okay, array of light passes through what? Principal axis will pass through focus. Array of light passes through what? Next we are going to see array of light passes through what? Focus. Let's take the focus, right? That is what we can do. So we will take like this, and then we can say here, yeah, array of light passes through focus. It will be what? Parallel to principal axis, right? So yeah, like this. Next is what? Again, center of curvature, focus, center of focus. Let's take F1. Optical center, right? This is what? Optical. Array of light passes through what? Optical center. Then what will happen, guys? It will what? Retrace its path, right? It will what? Retrace. This rays of light really reduce too much. It will retrace its path. The same thing we did there also. So no problem. Now what? For concave lens, right? So there, if you will see, array of light passes through principal axis, what will happen? Everyone knows, right? It will pass through focus. So here it is going to be little different. The way like how it will be, that is going to be little different. Fine, what is the problem? So we can say ray of light will what? Pass so we can say meet somewhere here, right? Actually this should be a dotted line, otherwise you guys will say that, yeah. So array of light, so it will bend towards the focus, right? So this happens, and then what? If array of light, Same like this, if a ray of light passes through focus, then what will happen? We also know that it should be what? Parallel to principal axis. If a ray of light passes through focus, right, passes through what? Focus, then what will happen? So here we can say if a ray of light passes through focus, right? See, it's passing through focus, so it will be parallel to principal axis. Center of curvature means it is going to be what? Same, right? So this we had done about what? Ray diagrams. Next we are going to see how image is formed. How image is formed. Same guys. See there now. Here is what you will have to see. Okay, let's see now. Properly we will. If you'll analyze this, then what is concave and convex? Wait. I'll so that you will imagine properly how this came into existence. Yes, perfect diagram. Now, guys, if you will see properly, we can say little you have patience here, you'll understand what I'm trying to say you from here. So that part is the lens, right? If that part is the lens, think about it that this lens consists of what? See, a sphere, right? Complete sphere. So we can say that lens will have some focus and of course center of curvature, right? This will also have some focus as well as what? Center of curvature, right? But here how we are writing is, here we are writing like this. Wait, I'll tell you in book how they wrote, so that I'm going to say. So they didn't consider this f1 f, right? Everything they wrote in the form of f1 f2 only. Let's consider, suppose if you are considering this is at f, this is f1, so they will write center of curvature as 2f1. This they will consider f2 and they will write center of curvature as 2f2. Now let's see guys. Finished. Hope so you guys got it. So what is this? Let's remove this. So hope so you understood what I'm trying to say you, right? And this is what? Optical center. So we can say in lens what? f1, f2, 2f1, 2f2 is what? 2f1, f2, 2f2. So f2 is what here? Optical center, right? There also 2f2 is what? Optical center, right? 2f2, 2f1 is what? Optical center. f1, f2 is what here? Focus of the, like two mirror is there, no? So for that two different focus, two different center of curvature. So we are writing by this way. So now we are going to see the image formation of what? Concave lens as well as what? Convex lens. So image formation, if you will see for concave and convex lens, same as what we did for convex and concave mirror. So if a ray of light is parallel to, if the object is at infinity, then image will form at focus. If the object is beyond C, then image is going to be what? Between C and F. If the object at C, then C, right? But this side, that side, that is, okay, we'll see these things. This all we are going to see now. Let's see. We'll proceed with these things. So okay, diagram will not be that good, but fine, you guys can understand what I'm trying to say. So focus is what? f1, and then we can say what? 2f1. Focus center of curvature, right? f2, 2f2, right? If the object is at infinity, then image is going to form at what? Object is at infinity, then image is going to form at focus. Okay, rays of lights will take what? Parallel. So we can say it is going to be what? Parallel to principal axis. So let's take a straight line. Okay, then again what? A ray of light parallel to principal axis will pass through what? Focus. Easy, right? So we can say the rays of lights are, if you'll see, actually meeting. So object is at what? Object is at what, guys? Object is at infinity. Image formed at what? image, three things if you will see here. Then what? Formed at focus, right? And then what? It is real, because actually rays of lights are meeting, right? Real and what? Inverted, right? Whenever it is real, then it should be what? Inverted. And diminished, highly diminished, we can say. Too small, point size object, highly diminished. Diminished. Okay, so this is about what? For first, right? If the object is beyond, beyond, I'll tell you. Let's change the color, so it should be in the same color. It will be easy for us to understand. Again, now we can say optical center F1 to F1, right? F2 to F2, F2 to F2, right? If the object is beyond C, then what will happen, guys? If the object is beyond C, then a ray of light parallel to principal axis will pass through what? Focus. Will pass through what? Focus. A ray of light passes through center of curvature. Next we can see. So what we can do, little we can displace this, otherwise we will not get the image. 2F. So the images we are going to get here, this is the image, right? So now what? Object is at what? Object is beyond focus. Images will form. Image, if you see three properties. First is what? It is forming at what? Between F2 and 2F2, right? Image is what? Real, inverted, right? Third is what? Smaller than the object, right? Diminished, we can say, smaller than the object, right? Let's see next. Now is what here? That now let's take at F. If the object is at F, you guys know what will happen. Right? Again, if it is at F, then what? Parallel to principal passes through what? Focus. Next, what we can say? Again, we can say if a ray of light passes through center of curvature, through what? Center of curvature, then we can say it meets somewhere here. I am adjusting little that you should understand. 2F2, F2, F1, 2F1. See, it is forming at what? If the object is at C, then image is also forming at what? C. So object is at C. Image also formed at what? Image, if you will see, at C. Real, right? Inverted. And then what? Same size. Right? Same size. Now what? Between, same thing, guys. There is nothing change in this. You will get the same thing here also as the mirror we did. F1, 2F1, F2, 2F2. If the object is between C and F, then what will happen? Beyond what? F2, right? Let's see. Right? So somewhere here. So we can say beyond what? Beyond C, greater than C. Now we can say object is at what? Object is at is in between 2f2 to f1 and f1, then image forms at what? Image, if you will see, that is going to be what? Beyond 2f2, beyond 2f2, that is what? Real and inverted, and then what? Enlarged. That is what? Enlarged. Right? Till here you guys understood. Now next is what? Next is till what we had done. Now at f, right? Now guys, if you'll see, these two rays of lights are parallel to each other. Parallel to each other means what? It will meet at what? Infinity, right? Obviously we know if the object is at focus, then the image is going to form at what? Infinity. So object is at what? Focus, image is at infinity, then what? Real, inverted, highly magnified. Highly magnified. Next we are going to see f1 2f f2 2f2. Okay, if the object is now, suppose here, let's take another color. Now we can see array of light parallel to principal axis will pass through what? Focus, right? That we understood. Second thing is what? Array of light passes through what? Center of curvature. Now if you'll see, both are divergent, right? It is not convergent, right? Like diverging it is, right? So it will never meet. It will never meet, then we'll have to extend these rays of light, right? So we can say somewhere here it will form, right? So now object is at what? Object is at what? Is in between focus and optical center. Then image will form is what? Virtual and erect first, and then we can say same side of the object, right? And the third is what? Magnified, virtual and erect, right? That also you should know. Then what? Uses, let's see uses. Convex lens ray diagram we'll see in the next class anyway. Convex lens uses, if you'll see, telescope, binoculars, spectacles, right? Lasers, cameras, flashlight, and then what? Peepholes, right? Magnifying glasses, eyeglasses, cameras, microscope. These are the uses of what? My concave lens as well as what? Convex lens. Till here we'll see in this class. Next class we are going to see what? Again one more topic we can do. What if half portion of lens or mirror is covered? So of course you will get the image, right? But the thing is what here? If it is half covered, then what will happen? Suppose if the object is here, then we will suppose this is what? Focus and f1, and this is what? F2. So somewhere here beyond what? 2f2, right? So somewhere here the image will form, but the brightness will be what? 50% less. Brightness will be 50% less, right? That we should understand. That's it. So this we'll see from here that what? 50% brightness will what? Decrease. Fine. So you guys revise till here. We'll see in the next class.